This is a video on a more complicated U-substitution that involves logarithms. The question is to integrate 2x minus 1 divided by 3 minus x dx. I use U-substitution, and I let u equal 3 minus x. Then take a derivative, and du equals negative dx, and solve for dx by multiplying by negative 1, and we get negative du equals dx. So we now have the dx covered, we have the 3 minus x covered, but we have this x up here that isn't going away. So what I do instead is I solve for x in this first equation. And when I do that, I get x equals 3 minus u. Now I'm ready to substitute everything in. And what I get is 2 times x, or 2 times 3 minus u, minus 1, and then divided by 3 minus x is u, and then dx is negative du. So now let's simplify this. I multiply the 2 through and combine like terms. 2 times 3 is 6, minus 1 is 5, so I get 5 minus 2u over u du. Now one more piece of algebra. I'm going to split this fraction up and multiply the negative through. So I get negative 5 over u. Then we have a negative. 2u over u is 2. So I get the integral of negative 5 over u plus 2, and that's an integral I can handle. So the integral of negative 5 over u is just negative 5 times the natural log of the absolute value of u. The integral of 2 is 2u, and then I always add a constant. I'm adding plus c sub 1 for now, and we'll see later why. So now let's resubstitute. We know that u is 3 minus x, so I substitute where I see a u, I have a 3 minus x. And now if I multiply the 2 through, 2 times 3 is 6 as a constant, and I can incorporate that constant 6 in with c1, call that a new constant c, and then also 2 times negative x is minus 2x. And my final answer is negative 5 natural log of the absolute value of 3 minus x. There's my minus 2x, and our c, remember, was 6 plus c1, so I go plus c. And I'm done with the problem.